Good evening. Let's start with exercise. Today we will do some shoulder push-ups and pull-ups. Okay. All right. Okay. Oh. Whew. 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 Yeah. Oh. Woo. Oh. All right. All right. Ah. Whew. Ah. 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 Oh, that was good. Right? Oh boy. Wow. So it's been like 30 minutes. Okay, we'll take 5 minutes break. Oh, wow. Good stuff. Ah, 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 Yeah. Oh. Happy Friday. Yeah. Whew. Yeah, it's quite chilly today. Let me put some extra layer. Oh. Okay, so we've been doing a lot of economics, I mean mathematics. We didn't quite get into economics yet, but we can take a break from mathematics, economics. You see, I'm sucking it in, right? Otherwise, it will bulge out. So, ah, ah. Okay, so let's take a break from mathematics, economics, well, mathematics for economics, and get back to humanology. But before that, I want to share with you something I learned long time ago. Uh, Something I kind of reviewed in my spare time. It's about semiconductor. Okay, yeah, read some articles about transistor. Interesting history around the invention of transistor. Uh, yeah, let's grab some drinks. Yeah. Okay, let's get ready. Oh. Let me wash my face real quick. Ah. It's kind of interesting. This well water never freezes. I mean, I heard some from Alaskan friends of mine. Sometimes their well freeze, but this well never has. So in Alaska, when we go to a long vacation during the winter, yeah, we keep the water on. Like just drip, 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 just a little bit. Okay. Otherwise, it may freeze when we go on a vacation. Okay, because running water, yeah, it's kinetic energy, so it keeps the water fluid as opposed to being frozen. Okay, so yeah. But still, it's kind of interesting. I mean, there's no electric heater down there under the ground, okay, but they never freeze, which is interesting. Let me refill this vodka real quick. Ah. So, back in the days, what year? I think it's like around World War II. Uh, there's this very brilliant American physicist who got Nobel Prize eventually for inventing the transistor, like PN junction, that kind of stuff. Okay, his name is William Shockley. Okay, very controversial figure. Uh, was Nobel Prize winner in physics and for invention of the PN junction, the semiconductor transistor and stuff. There's this biography. I don't know when. Let me look it up. Biography. There's this book. What year is this book? 2007. 2006. Yeah, the book came out. Biography of Mr. William Shockley, Professor William Shockley. He was, I think, he was professor in Stanford or something. Okay, this is he's responsible for creating the Silicon Valley and also transistor. I mean, there are some other people. Okay, but this guy is something. Okay, he got Nobel Prize and A controversial figure. Some people say he's racist and eugenicist. Well, the thing is, uh, he thought African Americans are not as by their genes, not as intelligent as other races. So people call him racist. But I don't think it's fair to call him racist. Okay, it's just that he was wrong on that account. But hey, nobody's perfect. Okay, uh, because even today, many people think intelligence (IQ) is inborn trait. Like some people have better gene in the brain, and for the brain gene, intelligence gene. Even nowadays, some people think that way, but I don't think so. I think intelligence is about discipline of studying. I think it's nurture as opposed to nature. Okay, that's my opinion, and that's the position of this humanology takes. It's all about discipline, and I don't think discipline is genetic. I think discipline is something we learn from our parents, grandparents, teachers. All right, I think it's more nurture as opposed to nature. Okay. Um, yeah, I mean, I love mathematics now, but not too much. And when I was a kid, I hated mathematics. I really hated it. And I was not as good as other students. We're talking about elementary school, for second grade, okay. But I had to learn mathematics, so I did. And later, after I learned it, I came to love it, okay. Um, so yeah, I think it's just culture, nature, not nature, but nurture. It's nothing but copium channel. Initial resistance, right? But as you do more and more, flow more copium in copium channel, the resistance decreases. And sometimes resistance even go negative. You get addicted to it. Okay. It takes energy to stop that activity. Intention, artificial energy, purposeful energy. It takes energy to stop. Okay, because it's downward channel. It takes energy to stop the water from flowing down there. Okay, so that's the downward copium channel with negative resistance. Okay, so anyways, so yeah, he was wrong on that account. But even today, many people still think intelligence is genetic. All right, and we disagree. Okay, it's about copium channel. That's all it is, really. Yeah, because copium perception channel, right? It may lead to development of copium action channel. Okay, like some person grew up in very criminal neighborhood. They watched crimes happening right in their neighborhood, even in their family. Okay, and then later on they actually do it themselves, commit crimes, violence. Okay, so it's relationship between copium perception channel and action channel. Okay, copium perception it decreases the resistance in copium action channel. Okay, so okay, yeah. Learning by imitation. Okay, so it could be good, it could be bad. Okay, it's another way to look at it is the spread propagation of metaphysical gene, metagene, selfish gene. Okay, ideology. Okay, yeah, just like virus is spread from person to person. Okay, so but in copium, I mean ideology, it doesn't even have to be person to person. It can go through medium like books, internet, television, movie, songs. Okay, yeah. It can spread through medium. Okay. So, anyway, so was semiconductor? Well, it's halfway between insulator and conductor, right? So what is conductor and what is insulator? Well, it's like this. Okay. Uh, um, like silicon, for example. You have silicon, right? Yeah, it has four arms. The so silicon crystal, it has four these electrons on the outside. What's it called? I forgot. Okay. So this is very stable structure, right? Because these two electrons in the middle, you have nucleus like neutrons and protons, which is positive charged, and electrons, they're negatively charged. And it's very stable this way because these two electrons, yeah, they repel each other. However, these electrons is stable because, well, sometimes they write like this. Okay, this electron is bound by protons in the middle of this silicon and also in the middle of this silicon. Okay, so bound by both protons. That's why it's very stable structure. Although these two electrons they repel each other. Okay, because inside of the silicon there are a lot of positive protons. Okay, so yeah. Okay. Yeah. How about nitrogen molecule? It's a triple bonding. Okay, so three electrons. Actually, it's not even. It's six electrons. Okay. Yeah. How about oxygen? Yeah, four electrons together. Okay. Yeah. Double bonding. Hydrogen. Yeah, just two electrons. Okay. Yeah, covalent bonding. But you have a lot of these positive protons in the nucleus of these atoms, right? So somehow it overcomes this electron repulsion. Okay. Yeah. In detail, I don't know. How about quantum mechanics? I'm not a huge fan of quantum mechanics. Okay, I don't think they explain anything. Quantum mechanics. Okay, they think they know something. They think they understand this better than others. I doubt it. Okay, they think they do understand better than others, but I don't think so. I'm not a huge fan of quantum mechanics. Okay, so uh, well, let's just look at hydrogen, right? Yeah. Okay. So let's think why this is stable structure. I'm sorry. Let's see why this is stable structure. Okay. So this electron is repulsed by this one electron, correct? But it is attracted by two protons. So it's obvious who wins, right? I think this is better theory than quantum mechanics. Okay, just by the number, this electron is repulsed by another electron. Okay, but it is attracted by two protons. So you will stay here, as opposed to over there, there. No, you will stay right here because if the electron is right here, um, it is away from another electron, but it is also away from a proton. Okay. Let's think about that. This we'll do it later. Okay. Is this most stable structure? Well, the thing is, in this case, you have two protons separated by only one electron, and two protons they repel each other, right? But if electron is here, well, we better draw just another diagram, right? If electron is here, if there's some shielding effect, some cancellation of repulsion between two protons, some cancellation effect, right? You can kind of mathematically prove this, right? Yeah, like enthalpy, whatever, entropy, whatever, energy level, Gibbs free energy, whatever, right? And then you can calculate, prove, mathematically prove that this is the most stable structure, okay, as opposed to this. Because here you have two protons, they will repel each other. There's only one canceling element, one electron between, right? So they will probably get away from each other, two hydrogen atoms, okay? But here, yeah, two electrons, they repel each other, but it's you're attracted by two protons. Each electron is attracted by two protons, right? Yeah. And two electrons are shielding the repulsion between two protons, right? Hmm. So that's the intuitive understanding why this is most stable structure, the hydrogen uh, molecule. Okay. Yeah. So that's the basic idea. Okay. Attraction, repulsion, and the shielding effect. Okay. The canceling of electric field force, right? Shielding by electrons go between two repelling protons. Shielding effect. Okay. Yeah. So that's the idea. Okay. That should be enough. We are not going to go into detail. All right. We don't have time. Okay. So yeah, silicon is like it's like kind of diamond. Okay, carbon, which also has four arms, right? Yeah, so silicon is silicon crystal is not semiconductor, is insulator. Okay, because you don't have any electrons hanging around. Okay, but conductors, my guess is that conductors have so many these external uh, electrons. Okay, metals they tend to be very heavy, so they have a lot of electrons. Okay, so pure metal crystal like iron, pure iron, okay, they have a lot of electrons hanging out. Yeah, they're electrically neutral. Okay, the number of protons and number of electrons they match. So they are not ions. Okay, but those why is ion or conductor when carbon or silicon is not conductor? It's because when for example, I don't know either exactly, but let's say, don't call me on this, okay? Let's look at the periodic table. Chemistry. Book right here. Let's look up iron. Its molecular three-dimensional structure. Okay, what it looks like. By the way, the neighborhood mood, residential mood is still hanging out in this area. Okay, when I was coming back from work, I saw it. Lovely. I love moose. They're so cute. Electron configuration of ion. Okay, 990. Very later in this book. Yeah, some interesting article about harvesting horseshoe crab's blood, blue blood that contains copper. How interesting. They use it for some kind of pharmaceutical purposes, chemical purposes. Okay, whatever. It seems iron has three arms, three external uh, electrons. I don't know. Okay, yeah, but conductivity has to do with some free, loose, superficial electrons. Okay, so that's all I know. Okay, so I guess these metals they're heavy, right? Most of them. So they have a lot of protons, a lot of neutrons, and a lot of electrons. Okay, as it get bigger and bigger. Okay, yeah, I guess the surface electrons sometimes they run away. I guess I don't know. Easier to run away because it's so far out, right? Oh boy, because it's gravitation, it's inverse square law, right? If well, but the thing is, if the distance between electron and protons is very far away, very weak electric force. But at the same time, big atom have a lot of protons inside of nucleus. Okay, so they also strongly binds this electron too, right? Yeah, yeah. Well, my knowledge in chemistry is kind of short. All right, so okay, whatever. Let's take 5 minutes break, okay, and then we look at we'll review this semiconductor. Okay, yeah. As far as I know, as much as I know, the little that I know, I share with you. Okay, understanding the inner working of semiconductor, like transistors, all that stuff. Okay, because it's so important. It's everywhere nowadays. All the electronics, yeah, they have this stuff. Yeah. Okay, let's take 5 minutes. Okay. All right. Okay. So back to silicon. Okay. So it took top scientists a long while and also some accidental discovery. All right. Yeah, some gift from God. By accident, they discover something like silicon crystal. There was some crack, and yeah, all that stuff. Okay. So. history of silicon semiconductor. Yeah, so yeah, what they do introduce was this. Okay, they it's called doping. They pollute the silicon, pure silicon, with some other atoms. So P type, well, we use N type first. Okay, N type semiconductor. Uh, use silicon, right? And you have one more. Okay, yeah, four external electrons, and then let me look it up. Okay, some example of this atoms with five external electrons. Okay, so let me look it up real quick. N type semiconductor. We go to Wikipedia. What are some examples of they call it valence electrons, external electrons. Okay, so outer electrons. Okay, okay. Phosphorus. Yeah, we use phosphorus. Okay, phosphorus have five valence electrons, the outer electrons. Okay, so phosphorus. Okay, it has one more electron. Okay, so that's just hanging around. It's not bound by other silicons. Okay, but they're electrically neutral. Okay, yeah, the number of electrons in phosphorus and the number of protons in phosphorus atom is exactly the same. So they're electrically neutral. However, if room temperature is more than absolute zero, okay, this electron has some kinetic energy, so it moves around. Okay, sometimes it travel. Okay, it just go away, making this phosphorus an ion, positively charged ion, because it lost one electron. Okay. Yeah, there's quite a lot of narrative concepts in this semiconductor. Okay, so it took top scientists, top physicists, chemists a while to discover this. Okay, yeah, and it opened up the electronic age, electronic gadgets. Before this, they used vacuum tube, right? Vacuum tube. It was too big, took too much power, energy. It was not practical. Back in the days, computer was like as big as this room. Okay, just regular computer. Let alone supercomputer. Okay, but nowadays supercomputer is probably as big as this room. Okay, but just regular computer like ENIAC or whatever, Mark One, whatever. Okay, It was just regular computer. Okay, it was not supercomputer, but they used vacuum tube instead of this molecule based, material science based. Okay, so and it was very expensive, very bulky, and took a lot of power, a lot of air conditioner. Okay, but they are physically equivalent, electronically equivalent, vacuum tube and transistor. Okay, basically they, from what I understand, they basically like they're switches, like zero and one. Okay, they store this digital information, boolean, zero or one. Okay, switches, on, off. Okay, that's my basic understanding. Okay, my electronics knowledge is very short. I did not major in electric engineering. Okay, so took some physics class. That's all. Very limited knowledge. Okay, so the first time I learned about this was in high school, middle school in South Korea. Okay, and I didn't quite get it. Okay, back in the days, but nowadays, yeah, I learned more physics. So, and I reviewed this during my spare time, Wikipedia and some other websites, YouTube. Okay, and I have better understanding. Okay, just semiconductor. Okay, so all right. So this is N type semiconductor. Okay, and how about P type? Yeah, let's look it up. What are some examples? Let's do image search. Boron. Okay, yeah, boron. All right. It's boron. It's not M. It's B. Okay, some joke. It has only three external. It only has three external electron. Okay, so there's this hole in here. Okay, they call it hole. All right, I'm not making this up. It's like lack of electrons. So right, like anti-electron, but it's not proton though. Proton has a mass. Okay, but it's just lack of electrons. So relatively speaking, it's positive. Okay, so they call it hole. Yeah, it's kind of like copiomology concept, lack of copium, negative copium, okay, right? Lack of food, hunger, right? Yeah. So in this humanized paper writing, I'm kind of experiencing this scope creeping a little bit because I'm not sure when it's going to get done because we have so many things to say in copiomology, humanology, but it may take a couple of more weeks to finish this paper. But that's fine. We have some precedents. In last year, one paper was like 80 pages. Okay, so it was more than 50 pages. Right now, this copiamology paper is about 50 pages. Okay, yeah, it may take a couple of more weeks, maybe 20, 30 more pages. No problem. We'll take time. Okay, we'll take it slow. But, okay, so yeah, boron, it has only three valence electrons. So one is lacking electrons, so they call it hole, lack of uh, electron, right? Relatively speaking, is positively charged. So yeah, that's P type. P for positive, N for negative. Okay, so yeah, N-type semiconductor, P-type semiconductor. Okay, uh, so the carrier of electricity here in P-type, that's whole. Okay, the void vacuum of electron, relatively speaking, is positive charge. Right? N-type semiconductor, yeah, it has one electron. Okay, so yeah. Okay, there's some similarity with copy homology, right? Yeah. Will I talk about this in this humanology paper? Maybe, maybe not. Whatever. Okay, we'll take 5 minutes break, okay? And then we'll talk about NP junction, PN junction, okay? This is kind of interesting, okay? So, and we can draw some similarity between humanology and this semiconductor physics, okay? Uh, yeah. We'll make an attempt to make some analogy between humanology and this semiconductor physics, okay? Engineering, yeah. Material science, chemistry, okay? All right, let's take 5 minutes. Answer for correct. Okay. Okay. All right. PN junction. So your P-type semiconductor and next to N-type semiconductor. Okay, so but they are electrically neutral, both of them. The number of electrons matches the number of protons. Okay, it's just that in terms of covalent bonding, right? These guys, you have these holes. Okay, if this hole leave, then it becomes an ion, negatively charged ion. Okay, because this hole is kind of hang out there. Okay, and in N-type, this electrons, right? This not extra electron, but loosely bound electron. Okay, they can hang out, not bound by covalent bonding. Bonding. Okay, but they are both electrically neutral. Okay, so but once this electron or this hole get away, then it becomes negatively charged ion. Here, electron go away, it becomes positively charged ion. Okay, so okay, yeah. And they talk about diffusion force. Yeah, well, it's not exactly force like entropic force. It's not exactly force per se, but it kind of looks like force, so we call it entropic force in humanological physics. Okay, and then they call it diffusion force. Okay, so yeah. So some these loose electrons not bound by covalent bonding, they cross over this barrier. Okay, but not too many of them. Okay, not too many of them. Why? Because once this hole lives there, and once these electrons live there, there's some repulsion between this negative ion and electron. Okay, but by the diffusion force, they reach some kind of equilibrium and have this width of this stripe, this barrier. Okay, yeah, they reach some kind of equilibrium to have this fixed width, right? Well, I guess it depends on the density of this doping impurity, okay, of boron, of phosphorus, right? The width, yeah, it will change depending on the density of this doping material, impurity, okay, so we can kind of we are kind of beginning to see some analogy between the left and the right, conservatives versus liberalists, in politics, right? That's why it was so fascinating. Okay, yeah, I saw some similarity. That's why we are doing this. Okay, the semiconductor theory may have some application in humanology. Okay, that's why we are doing this. Okay, I was so fascinated by this analogy possibility. Okay, you left and right. Okay, some of them in the borderline. Some of them become more crossover and become liberalists, and some ex-liberalists cross over the boundary and become conservatives. Okay, some buffer region. Kind of, yeah, center left, center right, right? Bridging the gap, kind of, yeah. And the picture gets more interesting when we apply battery. Okay. Yeah, forward bias, backward bias, your battery, you connect plus to the P-type semiconductor, then it's like forward bias. backward bias, yeah, you connect the negative side or battery to p-type positive semiconductor. Okay, how interesting, right? Yeah, it's like you have liberalists and you have conservativists during the time when majority is liberalism. What happens? During the time conservatism is mainstream. What happens? Okay, so yeah, that's why I was enthralled by this semiconductor. Okay, because this we can see some potential for humanological application out of this. Okay, how interesting. Yeah, it is fascinating. Okay, so yeah, these free holes cross the boundary. Okay, by diffusion, entropic force, diffusion force. Okay, but not much because when negative electrons leave this n-type semiconductor, what's left is these positive ions, and these positive holes and positive ions they repair each other. Electron and negative ion, yeah, they repair each other, right? Yeah. So they reach some kind of equilibrium here. Okay. And they cross the boundary again. The electron is attracted to this hole and also positive ions, so they go back, return to the n-type semiconductor. They call it. I have to look it up. PN junction. Yeah. Yeah, this stripe is called depletion region. So many top scientists contributed to this invention of transistor semiconductor. Okay, so many different ones. It's beautiful. Yeah, Wikipedia is not doing very well on this. It's not quite giving me what I want. Let's go to another website. Wikipedia is not always the best. Okay, so uh, let me turn off the heater. It's getting too hot. Uh, uh. So electron going from N type to P type is called diffusion. But electron also go back, return to N type. Okay, what's that called? It start with D. I'm looking for that English vocabulary word. Oh, drift. Okay, there we go. Yeah, some Google keyword search keywords. Some previous people looked up the same phrase. Okay, so Google suggestion. Okay, diffusion and drift. Okay, you drift back. Okay, so yeah, electrons. Okay, and from N side to P side, there's diffusion. But electron encountering this negative, negatively charged ion going back, that they call it drift. So diffusion, drift of electron. Okay. Yeah, this whole we can call it positron, whatever. Okay. Yeah, it works the same way. Uh, Vice versa. Okay. Yeah. Diffusion and drift, drift. Okay. Reaching equilibrium. They call it depletion region, right? Depletion band. Okay. Let's take 5 minutes break, okay? And then we'll apply some forward bias, backward bias, which means you're connecting this pair of semiconductors, okay, with a battery and a pair of wires, okay? Well, forward bias is nothing but connecting the battery plus side, minus side, okay? Yes, with the two. wires, a pair of wires. Okay, so then let's see what happens. Okay, why don't you think about that if you want to? You don't have to. All right, if you want to. Yeah, we'll take 5 minutes and we'll compare the answers. Okay, what happens? Okay, okay, we'll take 5 minutes. Heavy. Yeah, it's really cool stuff, right? Yeah. Many top scientists, possibly like tens of thousands of top physicists, chemists, material scientists. Okay, they struggle with this. Okay, and then all around the world, in Europe, America. Okay, later on some other countries. Okay, so yeah, some Koreans too, some Arabs. Okay, yeah, they'll contribute to this. Okay, later on. Okay, so all right. Okay, we take finance. Yeah, I guess Science Friday, NPR, sure, whatever. Uh, uh, Okay, so yeah, physics, chemistry, mathematics, right? Yeah, there are rules. All rules. They're like ideologies, set of rules, right? Yeah, we're just going through this narrative in physics, chemistry, following their rules, like ideology, okay? Just going along. And it worked, okay? A lot of physicists in the world, yeah, well, back in the days, mostly Europe and America, okay? Yeah, they got it worked out, okay? Some accidental discovery, the cracked crystal of silicon under the lamp, right? Yeah, all that stuff. Yeah, very interesting history. Discovery of semiconductor, okay? Yeah. AT&T Bell Lab, Eastern Coast. Right, yeah, I read some of that. Okay, so it's not a very difficult concept. No. Okay, for bias. Okay, so what happens? So for bias, right? So you have plus battery and connected to this negatively charged ions, right? Which has extra electrons. So electron comes here because plus and minus they attract. How about in copiomology? Does negatively charged copium, negative copium, negon, and positive copium, boson, do they attract each other? Yeah, I was kind of wondering about that. Okay, so, well, we'll table that discussion later. Okay. Pain and pleasure, do they attract each other? Okay. Negative copium, positive copium. Okay. So that is very significant topic here. We are in the world of humanology, right? Yeah, that's why we're doing this. Okay. To draw some analogy. Okay. Humanology, that's very metaphysical. Okay. But this physics, physical. Okay. And in humanology, yeah, our premise, assumption is such that, yeah, metaphysical universe mirrors physical universe. Okay. But metaphysical universe, very difficult because it's invisible world. But physical universe, well, still a little bit difficult, but it's a lot easier than physical universe. Okay. Physics is easier than metaphysics because it's visible, right? Of course, atoms, electrons, they're so small, they're not quite that much visible, but metaphysical universe, that's just concepts, ideology, okay, is very challenging, okay, so we want to learn physics first in order to understand metaphysics. Because metaphysics, that's invisible, okay, concepts, ideologies, okay, there's a lot more difficult to understand. So let's do physics first, then we'll do metaphysics. Okay, so that's the ordering, learning. Okay, yeah. Sorry about this. Saliva slime. It happens when I'm kind of dehydrated. So let me drink some water. Right. Yeah, so in my bathtub, okay, if water is too hot, I turn the cold water, right, in my bathtub when I take a bath in the morning, Monday to Friday, before I go to work, like 7 o'clock in the morning, okay, so I feel so good, okay, that's like centripetal pleasure, right? My body is hot, but when I drink cold, ice cold water, beer, Diet Coke, whatever, it feels so good because centripetal homeostasis, centripetal pleasure, centrifugal pain. That's like away from this homeostasis, ideal body temperature. Okay, if it gets too cold, painful. If it gets too hot, painful. But when we are cold and come to a warm place, like fireplace, right? We are warming. Yeah, centripetal pleasure, right? When we are so hot and we come to this building with air conditioner, our body is cooling. Yeah, so the pleasure of cooling, centripetal pleasure. Okay, centrifugal pain. Yeah, I wrote down the note. I'm gonna write that in the paper. Copianology, humanology paper. Okay, maybe tomorrow. Okay. Anyways, okay. So yeah, these electrons they run away, right? Yeah. So this barrier, this stripe, they call it depression band. Okay, it shrinks. Okay, why? All this negative stuff go to positive end of this battery. All this positive stuff go to negative end of this battery. So yeah, this band shrinks, start to shrink. Okay, because the width of this barrier central stripe is defined as the number of electrons on the p side and number of positrons holes on the n side. Okay, but the width of this barrier band they call it depletion region for a good purpose. Okay, because they're kind of neutral here. Okay, so but when you connect this battery positive end, okay, all these electrons run away to meet these positrons. Okay, all these positrons run away to meet these electrons in the battery. Okay, so the width of this central region shrinks. Okay, the width is defined by the number of electrons here, number of positrons here. Okay, yeah, they shrink because they run away to meet this opposite charge. Even in humanology, yeah, sure, opposite gender. Okay, yeah, bachelor's party, your bachelorette's party. Okay, single guys, single girls. Okay, they marry. Okay, you're a bunch of guys, bunch of ladies. They become neutral. They marry away. Huh? Bachelor's bar, single bar. Okay, you're a bunch of guys flocking. Yes, birds of same feather flock together because they understand each other. They're the same kind, right? The bachelor's party, bunch of guys, single bar, and then you have females, bunch of females, birds of a feather flock together because they understand each other better than opposite gender. Okay, males, we are guys, we understand each other. Girls, they understand each other. Okay, so birds of the same feather flock together. Some American or English proverb. Okay, yeah. In Korean culture, yeah, 가재는 개편. Okay, meaning crayfish or lobster, they side with crabs. Why? Because they're kind of similar. Okay. Yeah, there's some Korean analog proverb to English proverb. Yeah, birds of feather flock together. Okay. Yeah, like like-minded individuals. conservatives or liberalists, they form a party, okay, because they agree on many things. Leftists, rightists, Democrats, Republicans, liberals, conservatives, okay. So they flock together, okay. They gather together because it's easy to be with somebody that you agree with, okay. Yeah. So positively charged particles coming together, attracting each other. So that's not physics, right? Negatively charged particles attracting each other. But in humanology, it's more than physics, okay? So yeah, it does defy physics, okay? Because it's metaphysics, okay? So like kind sometimes attract each other. It's agreeability, right? Yeah, we came up with some equation, feelings equation, right? It's a dot product, okay? Agreeability, right? Yeah. Like-minded individuals. Birds of a feather flock together, okay? Beautiful rhyming, kind of English proverb, okay, yeah. But at the same time, male and female polar opposites, men are from Mars, women are from Venus, right? This is kind of mutual complementation, okay? That dualism, right? They complement each other. We guys, tough love, females, soft love. So they kind of want each other, male and female, right? And they get married. Okay? Yeah. And have kids, children. Okay. Yeah. How about races? Well, we want to promote peace between races, but we want black to be blacks, white to be whites, brown to be brown. Okay. Because we want diversity of human race. We want Pomeranian to be Pomeranian, Chihuahua to be Chihuahua, German Shepherd to be German Shepherd, and we want authenticity, purity of subspecies, dogs, cats. We have Siamese cats, Persian cats, whatever cats. Okay, yeah. So when it comes to race, we want there to be blacks, whites, browns. Okay. Every once in a while, yeah, it's okay. All right. But 99% of the time, yeah, we want to say blacks marry blacks, whites marry whites, browns marry browns. Okay. Every once in a while, yeah, cross pollination. Okay. Yeah, that's fine. But most of the time, we encourage same race, opposite gender marriage. Okay. Same race marriage, well, that does not make any sense whatsoever. Okay. I mean, I'm sorry. Same gender marriage, it does not make any sense. Okay. Same gender marriage, LGBTism, ideology, it has no merit whatsoever. Okay. It's just LGBTism, same gender marriage, it makes absolutely no sense. Right. But interracial marriage once in a while, just 1% as an exception. Right. For 99%, yeah, same race, opposite gender marriage. Brown to brown, white to white, black to black, okay. 99% of the time. 1% exception, okay. But same gender marriage, LGBT ideology, yeah, there's no merit to that. Okay, there's just no merit. Okay, forward bias. Okay, yeah, the central band shrinks because negative guys, these electrons, yeah, attracted to positive guy, positive girls, whatever. Okay, yeah, positive girls here. Okay, girls club, boys club. Okay, boy scouts, girl scout, whatever, whatever. Okay, yeah, single guys, bunch of single guys. Okay, yeah, they marry, they meet the girls, bunch of girls, girls club. Okay, they marry guys. Okay, so yeah, population of single guys, population of single girls shrink. That's four bias in semiconductor theory. Okay, so we came up with some interesting analogy between physics and metaphysics, humanology. Okay. We take 5 minutes break. Yeah, I'm drunk. It's Friday. I'm at home. Yeah. Okay. We take 5 minutes break, and when we then after that we'll do reverse bias. What happens? Okay. You apply this negative and you just flip it. Okay. Battery. Negative part connected to this positive semiconductor and positive part to negative semiconductor. That's reverse bias. Okay. What happens then? Okay. Okay. I give you 5 minutes. Okay. And I give myself 5 minutes. All right. So yeah, we compare the answers if you want to think about it. You don't have to. Okay. Yeah, just relax. In humanology, we are very laid back. Okay. We take 5 minutes break. It's Friday. I'm at home. No problem. Okay. Okay, we're back. So what happens here? Ah, boy, this negative conjunction, backward bias, as they call it. Okay, so I mean, negative in physics, electricity, they repel each other, right? Yeah. So I mean, before this, okay, let's go back. Positive bias, forward bias, okay, yeah, right? So yeah, these negative guys, they meet each other, so this stripe shrinks, okay. But when it's reverse bias, backward bias, okay, it's supposed to expand somehow, okay. So I guess it's because yeah, these negatives goes away, right? So there will be more negatives here in this central band, right? The negative goes away, it becomes positive, so more negatives here, accumulation, okay? Vice versa, positive side, same way, okay? Yeah, so this stripe expands, okay? It's the concept of diode, right? Yeah, they convert from AC/DC, right? Alternating current plus and minus, like Nicholas Tesla versus direct current, Thomas Edison. Okay, so, yeah, I don't know. It's like this trap expands. What's the narrative? What's the logic behind this? Because it does not quite make sense to me. Okay, let me look it up. Okay, what's the narrative? What's the narrative? Backward bias. Backward bias, reverse bias. Semiconductor. Okay. Let me grab my coconut vodka real quick, alright? It's so confusing. Plus and minus, all that stuff. Ah, boy. Yeah, it is confusing. What is plus? What is minus? What's the difference, right? Eh. What is physics? What is metaphysics? Eh. Why are we doing this on Friday night? I guess because I'm single, I'm bored. Some intellectual stimulation, some intellectual challenge, right? Yeah, because we have some energy, disposable energy and time left in Friday night as a single person. So yeah, and we don't want to get into any trouble. Yeah, we just study physics, right? Reverse bias, right? Yeah. So what they are saying is the holes here, some positives. Okay, yeah, okay. They migrate to the negative side, so accumulation of negatives. Okay, okay. Yeah, some positives here. Okay, holes. It migrate. Okay, to this negative strong battery. Right. So it become more negative. It become more polarized. Negatives accumulation. Okay. And here, same way, some negatives, okay, it get attracted to this positive side of this battery, mainstream, big ideology, whatever, okay. Yeah, it become polarized, okay, yeah, okay. Kind of makes sense, right? Yeah, this P type, it become negative, N type become more positive, so all the remnant, residual, minus go to positive, plus go to negative, okay. Just like in humanology, right? Yeah, it's more like this gender war, right? Gender war. Okay, men, women, they hate each other, so they become more males, single males, more single females. Gender war, right? Whatever. Polarization, extreme bipolarization. Yeah, extremization. The leftists become more leftist. The rightists become more far right, saturated with all the conservatives, all the leftists, okay, nothing in between, polarization, okay. Before that, forward bias, that's more like neutralization, okay. Yeah, male and female, they marry each other, okay. But in another situation, yeah, there are more single guys because they hate women, and more single females because they hate men, okay. So yeah, you have no LGBT. We don't do LGBT here. Okay, so single guys in humanology we are anti-gays. Okay, this particular brand of humanology. There are some other branches of humanologies. Okay, other brands, but in this particular brand of humanology, we are against LGBTism. Right? So a bunch of single guys, bunch of single girls. They are all heterosexual. Okay, just they are biding their time. Okay, but in this particular context, example, illustration, yeah, gender war, okay, but no violence. We are against violence, okay. It's a bunch of single guys, bunch of single girls, okay. Gender separation is like Korean high school back in 1990s. They want to study, right? No distraction, okay. Yeah, polarization, right? Bunch of single guys, bunch of single ladies, like back in 1990s, gender separation high school. Okay. Even in America, yeah, back in the days in America, yeah, gender separation high school, it did exist. Okay, some Catholic school, okay, all boys school, all girls school, Boy Scout, Girl Scout, okay, gender separation so that they focus on study. In America, is existed back in the days. Yeah, the Dead Poet Society, whatever movie. What's his name? Teacher in English literature, Hollywood actor. He was in the movie Hook, Peter Pan movie. Okay, what's it? Yeah, Robin Williams. Robin Williams. Mr. Robin Williams. Okay, yeah. So in America, back in the days in America, so corporeal punishment like spanking with paddle, yeah, it did exist. Gender separation, strong discipline in high school. You know what? Yeah, maybe after this episode, I will watch this movie, Dead Poets Society. Okay, Robin Williams, some elitist high school in America back in the days, all boys school. Okay. Maybe I watch that movie. Okay. In Amazon Prime. I don't know if it's free. Maybe I have to pay for it. Whatever. Okay. Yeah. I watched that movie when I was in Korea. Korean English to Korean translation, of course. Okay. Yeah. So sometimes polarization, right? Leftists, rightists, polarization. Yeah. This kind of today, year 2021, January, February. Yeah. I think it's February by now. But there are some other times when leftists, rightists, they come together, right? Male and female, they marry, have kids. Yeah, opposite gender, same race. Okay, if they want to have kids, right? If you are mature adults, yeah, you're too old to have kids. Yeah, then interracialism is allowed in humanology. Okay, yeah, if they're not gonna have kids anyway. Yeah, they passed the age of reproduction. Okay, then interracialism is allowed in this brand of humanology. Okay, but when they're gonna have kids, 99% of the time we recommend opposite gender, same race if they want to have kids. 99% of the time. 1% of the time, yeah, cross pollination, yeah, it's allowed as an exception. A few exceptions. Yeah, that's the Tao, the way of anti ultra interracialism in humanology. Okay. Okay, good enough. Okay, so yeah, you go to YouTube, Khan's Academy, whatever other websites, Wikipedia, some other websites. Okay, they can uh, they can teach you about semiconductor better than I can. Okay, so we wrap up for tonight. This episode. After this episode, yeah, I'm gonna watch this Dead Poets Society, Mr. Robin Williams. Okay, in Amazon Prime. I'm gonna watch that movie. Okay, okay. Yeah, it's kind of dark. A guy committed suicide. Okay, so I'm kind of debating. Should I watch this movie? Okay, because I don't like death, negativity. Okay, suicide. Whatever that death. But Mr. Robin Williams, who also committed suicide. Okay, it's so sad. Okay, but I think I'm gonna watch this movie though. Okay, so no suicide. Okay, we got mission on Earth. Okay, if I don't know what it is, well, I have to live to learn what my mission is. Okay. Same for you, same for everybody. We are religious in this brand of humanology, okay? We believe in God or gods, goddesses, okay? We believe in purpose of our existence. Raison d'être, in French phrase, yet the reason of existence. Maybe there's some reason that why we are here on planet Earth, okay? Yeah, we want to do our part, our job. So please live long. Diet, exercise, martial arts, cardio, weightlifting, be beautiful, be useful, have a job, do study, survive and thrive, right? So that's the main motto in this human knowledge series, okay? Survive, you go to day job to pay the bills, but go beyond that, yes. Thrive, right? Do something extra in your spare time, okay? Yeah, educate, learn, right? Learning input, educate output. Yeah, study, teach, right? Go about life, survive, thrive. Okay, diet, exercise, be beautiful, personal hygiene, whatever. Okay, yeah, low martial arts, self defense. Okay, right. Happy Friday, everybody. Okay, thank you. Good night. Bye. Thank you.